Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of exponential functions, specifically how we can find the domain and range using graphs, and we'll do it in 5 minutes or less. Now in Algebra 1 we are also looking at the domain and range of linear functions and quadratic functions. So these terms should most likely be known to you, but let's review them just in case we need to. This is your first time looking at domain and range. The domain is the set of all possible independent variable values. Now we have a shorthand for that. We normally just say they're the x values. And for the most part, that's going to be correct. But that's going to be our independent variable values. That's the domain, which means our range is going to be the set of all possible dependent variable values. Now this can change just depending on the function that you're looking at. So in shorthand, right, you're always going to be looking at the y values, but sometimes it's the f of x, sometimes it's the g of x, h of x, if they're really leaning into the function part of it. So it just kind of depends. But in short, we can think of our domain as our x values, our range as our y values, knowing that our range y values sometimes look like f of x or g of x. So what does that mean if we're trying to find it of an exponential function? Well, remember our exponential functions are going to be slightly different than the quadratic and the linear functions. Y equals a b x, and that x is going to be that exponent for us here. So when we're looking at this particular graph, what do we see? Well, we see that we have our x-axis here, we've got our y-axis here, and if we wanted to look at our domain, we will be looking at our x values, right? So we notice that our graph here, this is a part of a graph, it's going to be, it's starting right at that 0 right there. So it starts right there. So we can say x is greater than 0, because anything less than 0 does not show up on this graph. Now, what we need to keep track of is this graph does not show you if it's an open circle. We are going to say x is greater than 0, because that means we're not going to include 0. If it happens to be a closed circle, then that would be x is greater than or equal to 0. So if it's closed, we're going to include the number that it's on. If it's open, we're not going to include it. Range, we're going to be looking simply at our y values. And so you notice here that we are at -2. And other than that, it's going to be very similar, right? It starts at -2 and it simply goes up. We don't know how far it stops, so we're just going to say y is greater than -2 if it's an open circle. If it's a closed circle, we would say y is greater than or equal to -2. Let's look at another example. Now for this example, at first glance you might think, oh, that's just a linear function, it's a straight line, but look how it's straight right here and then it curves up just towards the end as it reaches 5, and it starts to curve down just as it starts to reach -5. So that is going to be an exponential function, not a quadratic or linear function. And so in this one, we are just going to be looking at the domain. Sometimes you'll need to find the domain and the range. Sometimes you're just going to be looking for one or the other. So for this particular problem, we're just looking at the domain. And let's say that we've got an open circle at -5 and a closed circle at +5. So what does that mean? Well, we could say that x is going to be, and when we have both ends here, we normally put x in the middle, right? We say x is greater than, but we point it this way, -5, because it is larger than -5. And then we say x is less than or equal to, because now we're going to pick up that +5. So we put it in the middle, and we say x is greater than -5, greater than or equal to +5, and that would be the domain of this function.